So for part 8 here, we're going to be looking on page 9, and you will need your periodic table handy, so hopefully you have that. If not, grab that out real quick. So hopefully you thought about this warm-up already, and you've read through the why for today, and most importantly, what you need to be able to get out of this, our target, is finding atomic number, mass number, and the number of protons as well as electrons for any element I give you on the periodic table. Today is one of our foundation days with the periodic table and learning what these numbers mean and how to work with them so that all year we can do some interesting things with them. So in this first part here, we need to first figure out what the atomic number is, okay? So if you look on your periodic table, you're going to see every element has two numbers, okay? And those two numbers are the ones that we're going to work with. So we're going to write them down here first, and then we're going to look at a periodic table so you can really see which one's which, okay? So what is the atomic number first? So that's going to tell you the number of protons. So protons, P-R-O-T-O-N-S, and it's going to be the smaller of the two. What is the mass number? So that's going to tell you what the average atomic mass is for that element, okay? So that what that means is it's going to be an average of all the isotopes that exist for that element, okay? So notice it's an average, which when we look at this on the periodic table, that's why it's going to be a decimal. That's not a whole number because it's been averaged up. So all the isotopes added together and divided by the number of isotopes essentially based off of how much they exist, okay? So like if you know anything about isotopes from other classes, carbon 12, 13, 14 are some examples of isotopes. Carbon 12 exists a lot more than carbon 14, so it's kind of like they took a weighted average of that. So that's why that atomic or that mass number is going to be much closer to 12 when we look at the periodic table, okay? But all you need to know is that it's an average mass of isotopes. For that element, okay? And it's going to be a larger number. And again, when we look at this, it's an average, so that's why it's going to end up being not a whole number, okay? It's going to have a decimal. So if we look at your periodic table, okay? If we look at this, and we look at any of them, so carbon's an example I just gave here. So you see carbon here. Carbon has two numbers, this 6 and this 12.011. This 12.011 is that mass number, okay? And it's an average number, which is why it ends up having a decimal. And you'll see that mass number is below the symbol for every single one. Notice every single one of them have a decimal point, and it's carried out to generally 3 places on this periodic table, okay? The top number, the smaller of the two, is your atomic number. So 6 for carbon means there are 6 protons that carbon has. So how do you determine the number of protons and electrons that that element has? You look at that atomic number, okay? So atomic number will be your answer here. We're going to practice this. So we're going to practice it with this table here, okay? Then you'll practice it some more, as you can see. Then we'll talk about a little bit as to why the layout looks so strange in the periodic table. So we're going to look for some different elements, and you're going to take a while to find them at first, but as we work with the periodic table throughout the year, it'll get easier. The first one we're looking at here is sodium, which is Na. So if you look at your periodic table, here's sodium to save you some time. If you look at that, we need to find out what the atomic number is, what the mass number is, and we'll go from there. So atomic number is the smaller of the two, that's up top, so that's 11. And the mass number is this other decimal number, which is 22.990. Okay, so we've got 11 and 22.9. You can round it if you want there. Okay, but that shows me that you understand that it's a decimal one. Okay, now the atomic number is the number of protons. It's also the number of electrons. So since our number is 11 for the atomic, that means it has 11 protons and 11 electrons. Okay, so once you know the atomic, those two are really easy because it's the same number. Next one is Si for silicon. Come down here, find silicon, it's over here. Our atomic number, the smaller of the two, that's up top, is 14. And our mass number, that's the decimal, is 28.086. We come back and we fill that out. So we've got 14 and 28.1 if I round it. That just shows me that you realize it's a decimal one. I know these boxes are small, so you can't write the whole number necessarily, and that's fine. Once we have the atomic number, that's the number of protons and the number of electrons. Okay, so it's 14. Next is Fe, which is iron. Go back to your periodic table. It's right here in the middle. Atomic is 26. Mass is 55.9. Okay, so we're just going to write that. 26. and 55.9. Okay. 26 is our protons then, and it's our electrons. Next is aluminum. Okay, so we come down here, find aluminum, it's over here. Aluminum's atomic is 13, mass is 26.98. So 13 and 26.9, which means our protons is also 13, so is our electrons. Oxygen's next. Come over to oxygen. Atomic is 8. Our mass is 15.999. Okay, so 8. Okay, and then we have 15.999. Just going to write 15.9. Okay, technically that'd round up to 16. But then our atomic is the same as our protons and the same of our electrons. So 8s. Last is argon, which is a noble gas, which we'll talk about next unit or next lesson here. But I see argon over here. 18 is our atomic. 39.948 is our mass. We're going to go ahead and put those in there. So atomic is 18. And then we've got 39.9. So 18 is also our protons then, and it's our electrons. Okay? So you're going to practice that more in a minute here. But the next thing we're looking at is, why does the periodic table look the way it does? So you might have thought, like looking at the periodic table, why are these two columns taller than all of this in the middle here? So why are we missing some stuff in here? Why is this again taller and then it goes even higher? What is going on with all this stuff down here? Okay, why are these blank and so forth? So I just want you to know that the periodic table, as weird as it looks and how it's laid out, is laid out this way because there are some things that helped organize it the way that it is. So one example of that is the atomic size, or literally the size of the element. If you look back here at this graphic I have here, hopefully you see that they arranged it so as you go down each of the columns, it gets bigger, okay? And as you go from right to left, it also gets bigger. So it's like they lined all of the elements up based off of their size to try to make it so that it makes sense on how that they put it together, okay? They also put it the way that they did based off of the different number of protons. So we start with 1 from the atomic number, then go to 2, then 3, 4, 5, 6, 7, 8, 9, 10, and so forth. So we go in order of increasing atomic number 1 at a time, okay? Like 11, 12, we keep going 13, 14, 15, 16, 17, 18, and we had to leave some gaps here based off of those properties like the size that we have here, okay? So just know that the periodic table, as weird as it looks in its layout, it's actually arranged that way for a reason, okay? And we'll talk through more of those kind of trends that helped arrange it the way that it did as we get through this year. So next I'm going to do some practice problems with what we've done so far. Make sure you can get atomic number and mass numbers, especially from the periodic table. And we'll be making sure you're good to go before we move on.